Okay, good morning everybody. Here in this section, I would like to present my research about process statistics of thermoplastic for producing injection molding product using online quality control in the injection machine. Let me introduce myself. My name is Riona Ehsan Media. I'm from Design Engineering Department, Polman, Bandung, and I'm to be here as a presenter in iCAST 2020. Okay, in the next 10 minutes, I would like to present about the background why I gonna find out about the research and how about the research goals and methodology, experimental technique, results and discussion, and also after that conclusion. Okay, without further ado, I'd like to first of all goes into the background why I going to research about the injection molding machine, especially the process statistic. Here I go to the injection machine. We know that injection machine is already known by the manufacturer, especially for the mold maker. So in the injection mold machine, we have some parameters to have. We have to configure where the optimal configuration, where the optimal parameters to have the good product for the production, and also the parameters of injection molding itself, where we have to use two-plate mold, three-plate mold, and also the advanced molds such as a stack mold, something like that, and also for the more advanced mold about the hot runner and also the system based on the experimental. How about the simulation base? We have know that the simulation base that reduce to trial and error activities in the field. Okay, with this research goal, this research purpose as an effective approach that integrates the process parameter of design optimization in order to help manufacturers in obtaining the best configuration that can be combined statistic of product batch to the online quality control of the plastic parts. Okay, here is the methodology in the next. This section presents to the proposed methodology for obtaining the best parameters process integrates with the existing online statistical best. It means that the statistical can be online on the injection machine. We can start from the collecting parameters process to the checking quality of molded parts. That is the existing statistical based on the data of in the injection molding machine. While conducting the experiments, statistical data and to ensure the quality product is involved inside of the machine. We can read on the machine display that the statistical optimization process that involves the parameters. We can decide that which one the product can be optimized. This product is go or no go. That means that we have to looking inside about the figure, the graph in the next section. Okay, here is the experimental technique that involves the engineering drawing of the LED lamp as the study case. We have the body outdoors, and also we define the runner, sprue, and gate. In this parameter, we have the barrel parameters, screw back position, injection speed, and injection pressure. which means that we can set the value of the parameter itself from the one of each level to the 3 level followed by the value of the parameter itself. Okay, after that we have to define the manufacturing, which one we use the injection molding machine. In this case, I use the Demag Ergotech 280-40. That is consists of the climbing force 2000 kilonewton and distance between tie bar 560 by 530 and mode opening stroke and etc. This is the parameters from the machine manufacturer as our parameters to have to define the design engineering of these kinds of plastic parts module. And after those parameters that can be defined, we have to define the which one the injection molding technique that can be used. In this case, I use the 2-plate mold as the producing the plastic parts product that can be used in the Demag Ergotech 284 machine. And also we have to set up the several parameters on the machine display, which can be displayed, and also we show that which one that the product can be optimized, the product collected or categorized as a failure product, and also the which one the trial parameters inside. This is the set of the machine actual here. The green one and the yellow one is actual parameters on the machine. We can see on the machine display, we say that the actual parameters on the machine cannot connect or synchronize the product, the parameters that we need to involve in this research area. That means that we have to know how to configure the optimal parameters so that the actual setup, this is not too far away, the value of the actual parameter here to the setup parameters before. From those body outdoor slide lamp, I just define which one that can be optimized from this section. C1 as the diameter 28 and C2 as diameter 52 millimeters. This is a result and discussion based on the 30 batch parameters. Okay, so 30 product of each batch product that can be produced by the injection machine. We can define the parameters in categorizing the third or the 3 value of the each parameters. In this case, parameters that is lower temperature from the 260 degrees Celsius, and the level 2 270 degrees Celsius, and the level 3 in 280 degrees Celsius. And also from the screw back position, I just configure 16 millimeters, 19 millimeters, 22 millimeters. This screw back position, it means that can be involved or causing by the injection pressure inside of the molding itself. So we need to adjust the screw back position so that the injection pressure inside of the molding can be avoided. And this is the injection speed that we need to set up from 40 in the level 1, 50 in the level 2, and 60 in the level T respectively millimeter per second. Here for the injection speed, and also for the injection pressure we need to set up from 140, 165, 185 MPa, so that we know the result and discussion. We try to divide the discussion. Here's the weight as the response, final response, and C1 and C2 as the parameters that can be adjustable, or we need to looking out the dimension range. Here's the result. This is the weight that we know that from the batch production from 10 to 12, we have 1 or 2 here product that out of the range of tolerance, and from the batch 1 from 0 to 10, there is the lower base tolerance. The product have 2 lower base tolerance and 2 products in upper base tolerance. And also in the last batch of the weight itself of the product, we have 2 lower base tolerance. And also for the C1, is it okay based on the measurement in the field, in the laboratory. And also C2, we have in the batch 1 we have 1, in the batch 2 we have 2, and in the batch 3 we have only 1. So this is to sum up about this presentation today. The parameter setting in the injection molding machine, particularly in the product weight measure dimension C1 and C2, has been selected as the parameters that significant impact to the weight. So 30 sample by means of 2 cavities injection mold has been successfully examined. The control process dimension C1, C2 using online process has been applied in this case, with the representing of the control chart based on the result and discussion. Using the control chart, which means that upper tolerance and lower tolerance, we have to setting up the parameters of the injection mold based on that control chart. This proposed approach indicated good performance among the range of the parameters there, so that we can avoiding the value product as many as we can. So thank you very much for your attention, and if you have any question, don't hesitate to raise your hand and I will ask your question. I will answer your question. Thank you very much.